It's very, very difficult to get cancer when the mitochondria in your cells are healthy because cancer is a mitochondrial metabolic disorder. So you have to abuse your mitochondria in some populations of cells in some organ of your body in order to cause that cell, that cell or group of cells to start growing in a dysregulated way. So if you keep your mitochondria healthy, you don't get chronic diseases or cancer.
This episode is for entertainment and information only. The opinions expressed are not professional advice, and listening does not create a client relationship. Always consult your own qualified professional before making any financial, legal, or health decisions. Hello, and welcome to the Healthy Wealth Experience. I am your host, Chris Hall, and today I am really excited to have a guest with us today, Dr. Thomas Seyfried, and he is going to blow your doors off today with what he knows about cancer and the research of cancer and the direction that it's headed versus the direction it should be headed. So without further ado, Dr. Seyfried, thank you so much for being on the show.
Thank you, Chris. Nice to be here today.
All right. So thank you so much. So obviously I know a little bit about you, but tell us a little bit about yourself and, kind of how you got into this subject matter.
Well, I'm a professor here at Boston College. I teach general biology to students that are not biology majors, which includes a lot of my work on cancer as well. We integrate cancer into a lot of the foundational principles of the biological sciences. But I also teach an advanced course in cancer metabolism. So those two kind of keep me busy. And we've been working in this maybe 40 years at least, but not always on areas of developing therapies. Most of it was on basic research. What is the biochemical changes that you find in cancer? But before that, and parallel with that, I was also working on the field of epilepsy at Yale University, and I continued it here at Boston College. And we were mapping genes and developing therapies for epilepsy, and those therapies for epilepsy started to merge into managing therapies for cancer, and the two projects were parallel for many years. And now most of what I do now is mostly into the field of cancer prevention and management.
Okay. And so now you have been very well reviewed. You've been in 150 plus peer-reviewed publications. Is that correct?
Well, we have over 200 now. That was probably 10 years ago when that came out. So we've been publishing quite a bit. We have some new papers that will be coming out. One just came out yesterday on the glutamine issue, implementation of glutamine. And preclinical, we do all of our work preclinically, which uses the most accurate models for the disorder, both brain cancer and general metastatic cancers. I also work with many clinicians in different settings around the world who want to introduce metabolic therapy for their patients. So we're working on several fronts. We're starting a new society of metabolic oncology, which will be introducing non-toxic therapeutic strategies for managing cancer in people. The foundational concepts are developed here at Boston College using these preclinical systems so we can troubleshoot a lot of the issues before they go into the clinic and allow clinicians to be more comfortable in doing what they do without fear that they're going to harm their patients.
So your primary claim is that cancer is a metabolic disease, not a genetic disease. Can you kind of elaborate on that for people who aren't familiar with your work?
Yeah, well, our work is based on the shoulders of Otto Warburg, a famous German scientist from the last century who showed in the 90s with his data that cancer cells ferment the sugar glucose into lactic acid. And he said all cancer cells have this common problem, and it resides in the mitochondrion of the cell, which is the organelle that provides the energy of the cell, controls the quiescent or differentiated state, determines when cells grow, how long they should grow, how fast they should grow, and when they should stop growing. In other words, they would control cells to start growing and stop growing. And we've learned that over the years. And that organelle is deficient. Because it's deficient, cells no longer respect contact inhibition. They no longer respect the environment. They grow in a dysregulated way, which essentially is cancer. Cancer is dysregulated cell growth. And the regulation of the cell growth resides in the organelle called the mitochondria. And when that organelle becomes damaged or deficient in its ability to produce energy, a variety of different abnormalities can happen. The cell gradually drifts into an unregulated state, and as long as it has fuels to drive this energy, which is a fermentation energy, very hard to kill. So the origin of cancer is a disruption of normal energy metabolism and a replacement of this energy with ancient fermentation pathways. These are pathways that exist in all of our cells, and they're heirlooms of hundreds of millions of years ago, before oxygen came into the atmosphere. And these cancer cells are simply falling back on these ancient pathways. And as long as the fuels driving those pathways are present, they become very difficult to kill. So you can, poison and irradiate people and chop them up and do all this kind of stuff. But all you have to do is really pull the plug on those two fermentable fuels, and you can pretty much manage the disease in a much more effective way. But because people think it's a genetic disease, including the National Cancer Institute and most top medical schools and most pharmaceutical companies, you constantly are producing therapies and drugs that are incapable of dropping the death rate. And the beat goes on. And that's why we have over 1,700 people a day dying from cancer in the United States, which comes out to about 70 people per hour, and the beat goes on. And you keep hearing about all these new breakthroughs. The only major breakthrough was the anti-smoking campaign from the 1990s. This is another thing. When you hear, we're making so much progress. No, you're not. You stopped smoking. That was the progress. So it became socially unacceptable to be smoking in groups of people. So peer pressure gradually stop people from smoking, and that dropped the death rate significantly. Wasn't any new drugs. And you hear on the news, they're saying, we made so much progress in the development of, no, you haven't. We have 1,700 people a day dying. Tell me where the progress is.
Right.
They don't know that there's 1,700 people, 70 people an hour are dying, and they keep telling us we're making all this progress. We would have had a hell of a lot more people dying if we didn't stop smoking. So that's the big advance. It was the anti-smoking campaign, which is basically prevention. It wasn't any new technology. And then you hear about all this stuff that's just such misinformation and such bullshit. You keep hearing it on the news every night. Oh, look at all the cancer. Look at this drug. Look at that drug. And we have 50% of the people dying from the drugs that they're treating the patients with.
Right,
it's
right.
Tragedy. It's tragic.
It is incredible to me. I coach football and as a hobby, and I love coaching football. And we had a thing the other day where the kids were kind of just talking about why they play football, and it was a really cool night. But I couldn't believe how many of the kids basically talked about a loved one, a parent, a friend, a brother, a sister that had died of cancer or had been fighting cancer. And it was like, it really, truly, it touches all of us. So it is like, you can't even talk to anybody without someone saying, oh yeah, so-and-so's got cancer now. So you had mentioned the two fuels that feed cancer or fuel cancer. Can you tell us what those are?
Yeah, well, one of them is the sugar glucose.
Mm-hmm.
It's clear. We were the first to show a direct relationship in our preclinical studies on brain cancer, that there was, the higher the sugar in the blood, the glucose, let's put it this way, glucose, which is, if your table sugar is part fructose, which makes it sweet, and the other part is glucose. So when you eat table sugar, it's broken down in the stomach by sucrases, and you get glucose immediately enters your bloodstream. And diabetics can have very high blood sugar levels. So that's why they take metformin and these other kinds of drugs. But the bottom line is, what we found is that in these mice with brain cancer, the higher the blood sugar, the faster the tumor grew. And if you use various diet, like water fasting and diets and things like this, you could lower blood sugar, and the tumors grew much, much slower. And then people started to make these same findings in humans. The people with glioblastomas or brain cancers, the people that had high blood sugar survived the least amount, whereas those that had lower blood sugar survived longer. And then we saw the same thing for breast cancer, colon cancer, lung cancer. We went right down the list, pancreatic. The higher your blood sugar, the faster the tumor grows and the faster you die. And people knew for years that the other fuel, glutamine, which is an amino acid that's very abundant in the bloodstream, is there. And the tumor is just sucking down the glucose and the glutamine. And those two fuels are driving the dysregulated growth of these cells. It's really interesting. And then when you lower your blood sugar, your body starts mobilizing fat because you're not eating anything. And the fat triglycerides go into the bloodstream, and they go to your liver. And your liver kind of chops these long-chain fatty acids into small water-soluble molecules called ketone bodies. And they replace the sugar. So as the blood sugar goes down, the ketone bodies go up, and your brain and heart start transitioning away from sugar to these ketone bodies. So the nice thing about it is the tumor cells can't use the fatty acids or ketone bodies because the mitochondrion is needed to burn those ketone bodies into energy, and they have a bad mitochondria. So lowering blood sugar and elevating ketones then places the body in this new energized state where the normal cells get healthier and healthier and the tumor cells get weaker and weaker. And then we come in with very low doses of glutamine targeting drugs because there's no diet that can lower glutamine. It's just abundant in our system. And so we can strategically target the glutamine while we put a chokehold on the glucose and elevate the body over to ketones, which is the way we evolved as a species. Our ancestors during the Paleolithic period were always in a state of ketosis because there weren't delicatessens and donut shops on every corner. I mean, you had to kill the beast and eat the meat, and you needed a lot of energy to do that. And that's how we evolved. And these tumor cells, they're expecting a nice sugary meal every night, and all of a sudden you change their whole landscape, and they up and die. And you can gradually destroy tumor while making the rest of the body healthy. We see people that have high blood pressure, hypertension, diabetes, and cancer, and we see doing metabolic therapy, we see them getting rid of the cancer along with the diabetes, high blood pressure, hypertension. And exercise, we throw in the exercise, which puts even more pressure on the tumor, especially when the sugar is low and the ketones are elevated. So you can gradually manage this disease for all kinds, pancreatic, they're all the same. Cancer is one common disease of energy metabolism. We can manage all the, and so people say, well, I don't believe you. Well, why don't you read the damn literature? Why don't you look at the experiments that we did? You tell me where I made a mistake.
Right. 200 publications, right?
Well, it's not all on that, but a good 75 or 100 are.
Yeah.
And you tell me, I want to know, somebody come and tell. Nobody's been able to tell me where we made a mistake. And the science is rock solid. It's on a granite base. And yet we're not using any of this stuff that I just mentioned in the clinics.
Yeah, so
there's no clinical trial anywhere on the planet where we're simultaneously targeting glucose and glutamine while we transition the body over to nutritional ketosis. Nowhere. And yet that's the way we're going to manage this disease effectively everywhere. It's amazing, isn't it?
Yeah, it's incredible. Remember, Dr. Jason Fung, this is probably almost like a decade ago, was talking about reversing type 2 diabetes. At the time, type 2 diabetes was like a death sentence, if you will. There was no way to reverse it. And then he was like, no, you can absolutely reverse it. We just need to start fasting and eat a ketogenic diet. And I mean, here we are 10 years later, and people are still not fasting. They're still not eating ketogenic diet. And there's so many people that are anti-ketogenic diet. It's so crazy. Like if you go to a restaurant and you get a hamburger and French fries, nobody cares, you know what I mean? But if you get a hamburger and you say, I don't want the bun and I don't want the French fries, I just want the hamburger, well, all of a sudden, like you're some sort of weirdo.
Yeah. Well, I go to what we like is ribeye steaks. I don't know anybody who doesn't like a tomahawk ribeye. Well, maybe a vegan or something like that. But, you melt butter on top of it, man, it's unbelievable. And then you can have a small stick of asparagus or a small little bit of broccoli or something on the side. I don't consider that a hardship in any sense of the way.
No, absolutely not. Yeah.
We got really good results in our Greek glioblastoma study using a calorie-restricted Mediterranean diet, which was salmon, olive oil, little avocado, sardines, and this kind of stuff. And these people were doing really well. So when you say keto, it's not so much what we developed is the Glucose-Ketone Index calculator here at Boston College, which is going to eventually become the standard tool that everyone will be using to determine whether or not they are in the state of nutritional ketosis. So
what is that called again?
It's called the GKI, the Glucose-Ketone Index, which is a ratio of glucose to ketone bodies in your blood. And right now, the meters are basically a finger prick meter, like Keto Mojo or Precision Extra or these kinds of things. You can buy them on Amazon. But, people don't like to prick their finger to get the results you get are super accurate because you're measuring right from the blood. A lot of people with diabetes use these, kids with epilepsy. But now the companies are developing the continuous glucose ketone monitors.
Ooh,
so you just put the patch on your arm, and we're developing an app so you can read it right off your arm, right on your cell phone. And you'll know at any moment of the day what zone you're in with respect to your physiological health. And there's different zones. like the deep red zone, which puts you at risk for diabetes, dementia, cancer, cardiovascular disease, and all these different diseases that we are currently afflicted in our society, chronic diseases. You can have a blood sugar really high or a GKI ratio that's really high and put you in these. But if you want to prevent chronic disease, you can get down into the yellow zone. The orange zone is some sort of transition zone. But if you have a chronic disease like type 2 diabetes, like Jason Fung was telling you, or cancer or dementia, you can get down into these low green zones, which are low GKI values, where you're taking in very little carbohydrate diets, a lot of carnivore diets, a lot of exercise. You can stay in these low green zones and knock the hell out of these chronic diseases. You can either prevent them or you can manage them quite effectively. And then we bring in, standards of care that are currently used. And when you want to manage cancer, you can still use poisonous chemicals. The issue is you can use much less of them. So their toxicity becomes much less important. Even the immunotherapies will work best when the patients are in these zones. Right now, the field is throwing all this poisonous stuff at people before they get into these nutritional ketotic zones. But you see, the problem is right now, no one has a tool to tell you what zone you're in at any given time. So people say, I've eaten this crap ketogenic diet. It's terrible. Well, what zone are you in? I have no clue. Well, you might be eating a crap diet and you're not even in the zone that you think you're in. So without a tool, an accurate tool, there's so much speculation, and people sometimes don't even know where they are at any given time. So we're going to change all that.
How far out are we on this tool? This sounds amazing.
It's under development right now.
Okay. That's
so
great.
We're integrating all of the different parts of this as we speak. But we published the articles on it. We showed how the GKI can be used, and we have published articles showing people in low GKIs with the finger prick method right now. But we haven't brought the AI to bear on this yet. Artificial intelligence will make a lot of these tools a lot more easy for people to use, and that's all in the works.
I love that. That's so cool. I think I had talked to Dr. Chaffee, and he's a very carnivore kind of guy, and it's just like it feels like everything's sort of like swinging this way, but it also feels like the medical establishment is very slow to react, if not protective of the quote unquote old ways. Can you speak to that a little bit? Like, why is the medical industry so against, a ketogenic diet and, blocking glutamine?
I think the term diet has always been a turnoff for established medicine because it's so variable. I mean, it's so vague. What do you mean a diet? What you eat may not be the same as the other guy. And even if two people eat the same thing, the results may not be the same physiologically. So diets have always been ambiguous at best. The concept is nutritional ketosis, which can be a quantitative. We can measure that. And what you would need to get into nutritional ketosis might not be the same as what I would need or somebody else. It would depend on your age, your gender, your religion, your sex. All of these different things would have to be incorporated to know what one person would need to do to get into nutritional ketosis. So that takes the term diet out of it because it's a combination of yes, what you eat, but it's not a standard like, I'm eating a ketogenic diet. Some guy can get in there eating a carnivore or fish only or whatever. In fact, everybody should start experimenting with their own body to see what they could do to get into nutritional ketosis and then work it out for themselves so we can take the ambiguity out of a lot of this. So as far as the reaction to what we're doing, it's the science is solid, so you can't really attack that. So it has to be something other than attacking the science. Oh, it's hard to do. Well, none of it's done right. Oh, you want to live. It's up to you. You're in charge of your own destiny. If you don't want to live on the planet, then that's your prerogative. But the problem is people need to have the directions and the tools to do this. And right now, you're not getting any help from the traditional medical establishment. When you go to the cancer clinics, like we have Dana-Farber here and MD Anderson in Texas, and you have them Sloan Kettering and Moffitt's, all the Fred Hutch. You can go around the country and find all these cancer centers. It's shocking to know that most of the oncologists never heard of the fact that glucose drives the dysregulated growth of the tumor.
Right.
Can you believe it?
Right.
The very people that are supposed to be there to help you have no clue, not all of them, many of them have no clue about the biology or biochemistry of the disease they're trying to manage. And that's why we have 1,700 people a day dying. The very people that are supposed to know don't know. And now the people in the world are hearing about metabolic therapy, and they go into the clinics and they get slapped down. They say, "Well, there's no evidence to support this." I said, "Well, did you read the paper?" "No, we haven't read the paper." Well, how can you say there's no evidence when you don't even read the literature to know there is evidence? And of course, the drug companies aren't really enthusiastic about it. They prefer to push these very highly expensive drugs that have just as much probability of killing you as helping you, but they don't hide it. The drug companies are very open. When you hear them advertised at night on TV, Opdivo, Keytruda, this thing, that thing, they spend more time telling you how the drug is going to kill you than how it's going to help you.
Right.
You're not hiding it. It's absolutely telling you this drug can kill you. And yet people run and go to the clinics and they get the drug that could kill them. And they never hear about metabolic therapy. We can make those drugs less likely to kill you if you're in nutritional ketosis.
Well, you see, like, I feel like, this knowledge is so, obvious, right? You know what I mean? Everything needs a fuel, right? So like when you say, like, I don't know much about targeting glutamine, but I can tell you like pretty easy how to get rid of sugar in your diet. And maybe we can talk about glutamine in a second. But I think it's very inexpensive to do that, right? To cut things out of your diet is extremely inexpensive to do. I think that one thing that I always wonder about is like, for me, I know this information. I've heard it before. I'm super excited to get more information from you about it, from like, a true expert, not like, like some bro science thing that you see on the internet. But I guess what happens is like, for me, like let's say I talk to somebody tomorrow and it's somebody I went to high school with and they're like, "Hey, I got cancer." I'm like, "Oh my gosh, I'm so sorry." Like, it's such a leap to go from, like, "Oh, you've got cancer. Well, did you stop eating sugar and have you targeted your glutamine?" Like, it's like, you feel like, do I have the right to say these kinds of things? So what would you give advice to people to help spread the word about this without feeling like again, we're stepping on the doctor's toes, no doubt, because the doctor's already got him probably on chemo. You know what I mean?
Yeah, well, we're seeing the best results. Again, I'm not a physician, so I can't be telling anybody what to do or what not to do because I'm not licensed to do that. But what I am licensed to do is spread knowledge based on the publications that we have, and talking to my colleagues that are working in clinics using the new knowledge that we have. And generally, in many cases, when a person is first diagnosed with cancer, regardless of what type of cancer it is, some of them are surprised. Some of them knew there was a problem, but they didn't know it was as bad as it's been made out to be. When we get those folks up front and we put them on metabolic therapy right away, which is like a 0-carb diet for 10 days, and monitor their glucose-ketone index as they go through, their blood work is often screwed up at the beginning. They're at a metabolic homeostasis in many different ways, and you can look at the cholesterol and the triglycerides, the micro and the macro metabolites that you see. There's a lot of imbalances already within the bloodstream, which is indicative of a state of metabolic derangement. So we try to bring everything back onto a more normal thing, a normal platform, and you can do that by. But water-only fasting is a bitch when you try to do it up front. Don't tell me, man. Oh yeah, let's go out and stop eating. No, it doesn't. But after the third day, you look at your pets in a different way. This is very stressful on the body. But when you cut down carbs, you start easing your body into this new condition, and then jumping the last step into water-only fasting while you're taking medications that are specifically targeting glucose and glutamine. It's not so much of a problem. And you start to see shrinkage of the tumor. You start to feel a hell of a lot better. You start to see all these different changes. This is very dramatically different than what we're doing to the cancer patients today when you start pouring chemo into them or surgically mutilate them. We're not against surgical mutilation, but we like to do it in a more restricted and refined way. If you can take a tumor in someone's colon or on a breast or even in a lung, anywhere, even in the brain, and you shrink it down, you remove the blood vessels and you take this angry, inflamed growth and make it much less angry and inflamed, more indolent, then the surgeon can come in and feel with greater degree of confidence that I might have even cured this guy because I'm not worried about bits and pieces of the tumor that may have broken off or I didn't get it all or one of these kinds of things.
Right.
When you put patients on metabolic therapy, the damn tumor shrinks and the margins become sharp and surgeons look and say, "Oh my God, I can pluck this thing out. It's like a wart." But when you're dealing with an angry beast up front, a lot of times you don't cure the patient, you spread it around.
Mm,
And then you come in with the saturating doses of chemo or whatever else they're going to give you, with the hope you're going to kill all the tumor cells. But at the same time, you're killing your normal cells. Your hair's falling out, your gums are bleeding, your microbiome gut is blown to crap. I mean, everything is like, what are you doing to this poor? You're using medieval knowledge bases to get rid of something that's not as complicated as people made it out to be. I get frustrated because when we know and understand the biology and biochemistry of what's making a cell grow in a dysregulated way, knowing that there is only two fuels driving this dysregulated growth, and you're not targeting the two fuels that are driving the growth, and you're doing all these other crazy, expensive stuff that puts patients at risk for not only spreading the tumor, but for actually killing them.
right.
This makes no sense at all. But because I say this based on my years of knowledge and looking at the way we've been managing cancer here and publishing paper after paper after paper and having people in the clinics not reading the papers, and you say, why do you continue to do this crazy stuff? And it's mostly tragic in the little kids with brain tumors. They just surgically mutilate these kids. They irradiate and poison them. And even if they can stop the cancer, the poor kids are brain damaged from all the stuff they've done. I mean, this is tragic of the highest level. And yet we continue to allow this. And then they say, oh, you have to check your genetic profile. The genes have very little, if anything, to do with cancer. So we've opened up a whole new avenue of studying gene mutations in cancer that are largely downstream and irrelevant. The cancer cell can't grow without glucose and glutamine. Why are you worried about the genes? You kill the tumor cell, you don't have to worry about what kind of gene mutations they had in there.
Right.
They just awarded the Nobel Prize today for economics. It's called disruptive technology or creative destruction, where new sciences, new issues come along and eliminate old. New knowledge eliminates old ways of doing things. Nothing could be more central than the metabolic therapy for cancer. It will eventually become the standard of care because it works and it doesn't hurt. You actually get better and healthier when you do it. It's just a matter of time for people to realize that this will be the future. It works because I've seen it, and we just have to have it introduced into the major clinics. And because people are going to want it once they realize, and we publish more and more papers of people that have brain cancer and pancreatic cancer that are living 5 and 6 years when they used to live like 9 or 10 months. People are going to say, I want that. What is he doing? Can you let me do, I want to do what that other guy did. And they say, well, there's no evidence to support that. And the people the poor physicians in medical school aren't trained. They're trained to know that cancer is a genetic disease. The National Cancer Institute says cancer is a genetic disease. NIH awards all these big research grants to people hunting for genes that are largely irrelevant. So we get 1,700 people a day dying from stuff that these people don't have to be dying. So the whole industry needs to be turned upside down because it's not working.
Yeah. Yeah. How do people target glutamine? How do you do that? Because like you said, it's very prolific in our bloodstream already, right?
Yeah. It's already at a level that can satiate the desire for any tumor cell to have it. So it's the most abundant amino acid in our body. So we have to use drugs. But the drugs have to be done in a strategic way. That's why we developed the press pulse therapeutic strategy. It was based on evolutionary biology. It appears Ahrens and West, these two paleobiologists, wanted to figure out what led to mass extinctions of organisms on the planet over the history of our Earth. There had been these mass extinctions of organisms millennia ago. And they always found that it was two things. You had a chronic stress on the population, and then you had this unlikely, like a meteor strike or some series of volcanoes or whatever, and it would just wipe out everything. So I took that concept and said, okay, well, we can stress glucose down, and we can weaken the tumor cell by taking away one of the two fuels. And then because glutamine is so essential for our health that our gut needs glutamine, our immune cells need glutamine, Crip cells, we need that molecule. We can't go in there like a bull in a china shop and take away all your glutamine, because if you kill cancer cells, you won't have anybody picking up the corpses. You got to have your immune cells coming in and pick up the dead cancer cells. So you have to pulse. You give a dose of a glutamine targeting drug for a short period of time, just while you got a chokehold on the glucose with the diet, with the nutritional ketotic state, and then you come in with a pulse of a glutamine targeting drug. And now we find is some of these parasite medications are working well. We have data that mbendazole, which is and fenbendazole, these different drugs, they target this metabolic pathway, the glutamine. They target the glutamine pathway in the cancer cell the same way the parasite and the cancer cell require a similar pathway to survive. So the parasite medication kills the parasite, but it also will kill the cancer cell. And it's El Cheapo, right?
Yeah.
So nobody wants that. Oh no, you can't have that. So we have to figure a way. So we Scarelli the drugs. You remember Martin Scarelli, the most hated man in America? There was a big. Oh yeah, you can look back. He took the EpiPens and he jacked the price up several.
To like $800 a pen. Yeah.
Yes. That guy. He appeared on Congress and told them they were all fools at one of the congressional hearings, and he did it because he could. Well, the pharmaceutical companies do the same thing. They just don't boast about it. So they take embendazole, which used to be 50 cents a tablet. Now it works on cancer. Let's make it $300 a tablet. So, yeah, they do the same despicable, immoral. I call that immoral. There's a morality here that seems to be in short supply in some of these organizations. But, we can do that. And now we're realizing more and more some of these parasite medications. We have a paper that's out in bioarchives, and we have another one under review where we know this drug, 6-deoxynorlucine, is a very powerful glutamine targeting drug. But if you don't use it right, it can be toxic. It's like anything. You just got to know how to use the tools that you have. And once you know the strategies and the concepts, you can build a very, very effective cancer management system by your knowledge of what the tumor needs and your knowledge of how to use drugs and procedures in the right order and sequence. So this is not, this is the revolution. It's a paradigm change. And problem is nobody seems to be trained to know about this. They think it's a genetic disease. Oh, we got to target this mutation or that mutation. This is nonsense. It's not a genetic disease. It's a metabolic disease.
Right.
And once you know that, the outcome was going to be so much better.
Yeah, I feel like medicine is like diagnosis leads to prognosis, right? So if the diagnosis is misdiagnosed because they think it's a genetic disease, then of course the prognosis isn't matching up to, you know what I mean?
Well, they look at it. The ultimate way is you look at it under the microscope in a biopsy. And that's generally what everybody falls back on. Mm-hmm. Like, oh, you have a stage 1, you have a stage 2, stage 3, stage 4. They've been using this number system, for over 100 years now. I don't know. So you got a stage 1. Now they have stage 0s, where they think there might be something there, and maybe there is, maybe there isn't. But anyway, we'll remove breasts and we'll poison them, do all this kind of crazy stuff to some people. And then, oh, you got a stage 4. Well, what do you mean a stage? What does that mean? So you take the tissue out of the person's body and you look at it under a microscope, and you can see how many mitotic figures you see and how crowded the cells are, and this kind of thing. And the pathologist makes a decision that's then passed on to the surgeon or the oncologist to tell the patient, you got this kind of a disease, stage 3, stage 4, depending on how crowded the cells look and how many mitotic figures. The problem, which we've been doing for decades, is we take a biopsy of this thing, which is a section of the tumor, and then you give it to the pathologist, and he can make the decision relatively quickly. But you stick the beast with something that can actually make it worse and lead to the spread. I have dozens of articles showing how biopsies from breast, colon, liver, lung can spread the tumor through your body. Creating metastasis. Why? I say don't do anything. Don't poke the bear. Shrink it down. Make it weak. And then come in and take the whole thing out. What are you sticking it for? Just take the whole thing out after you shrunk it down with metabolic therapy. And then, and then what they say, which has been done, oh, this is not an aggressive, and they look at it and they go, oh, this is not an aggressive tumor. Yeah, because we shrunk the hell out of it. We already beat it down. I mean, if you stabbed it at the beginning, you'd say, oh, this is going to kill you, but it's everything you got to know about the biology. You don't poke the bear. Just take the food away from him. He becomes very docile, and you can cut it out. And then you can follow it up with some non-invasive imaging. We've got all these non-invasive imaging, CAT scan, PET scan, MRIs. You can start looking at things before you have to poke it. And if it goes away, I mean, why would you want to poke it in the first place?
Right.
So we have all these things available. We're just not using them in the correct order, in the correct way. But once the knowledge comes out, people will start realizing what I am saying and start doing things the right way.
Nice. And now, have you developed protocols? Do you guys have protocols that people, like if a doctor's listening right now and they're like, I want to learn more about this, Like that
Yeah.
they could get a protocol from you?
Yes. What we've just published a big paper in Biomedical Central on glioblastoma, and Dr. Thomas Durai, who works with me here in the lab, he's an MD, PhD, and we put on over 20 scientists and physicians, nutritionists, dietitians, all these people were on this paper together with us. And this paper starts the new Society for Metabolic Oncology. It's open access so people can get it. It's a very comprehensive treatment protocol for glioblastoma, which is a deadly brain cancer. The cancer that killed John McCain and President Biden's son and Senator Kennedy and many others died from this type of the same kind of tumor. So we've developed a treatment protocol for this tumor. But to be honest with you, all the cancers that we have looked at, whether it's a lung, a colon, a breast, a bladder, they all have the same problem. They need glucose and glutamine and can't burn ketones or fatty acids. So this protocol, we did it for glioblastoma because they've got nothing. We haven't made an advance in managing glioblastoma in 100 years. Can you believe it? Yeah, it's a tragedy of the highest level, mainly because they irradiate the brain of these poor folks, freeing up massive amounts of glucose and glutamine in the microenvironment, leading to the rapid demise of the patients. So even the very treatments that we're doing are facilitating the rapid demise of the patients. And then when you bring it to their attention, they get angry. Rather than saying, oh, geez, thank you so much for that valuable information, they get pissed off at you. So I said, what's going on here? Aren't you interested in the patients? You've been doing the same stupid thing for all these years and nothing's changing. And you want to come along with something that could work and you get angry about it? I mean, give me a break. But this is the crazy stuff. But the protocol for glioblastoma could be used for lung, colon, breast. Again, it's the strategy of pulling the plug on the fermentable fuels. You move in a little exercise, you measure your GKI, and then you bring from a very dangerous situation to a less dangerous, more manageable situation where you can sit back and think about the best new strategies that we can apply to the patient and the problem and gradually degrade the tumor slowly. We're not ever claiming that we can cure cancer. I hate the word cure, such an arrogant term. We like to think of managing cancer effectively, allowing the patient to live with a high quality of life, whether or not the tumor goes away, because we have this one guy, Pablo Kelly, who just passed away last year. He lived 10 years with a glioblastoma. He got married and had 3 children. He was never cured, but his tumor was put into an indolent state. And, glioblastoma patients, if you can get 15 months out of somebody rather than 122 months, I mean, he died from a cerebral hemorrhage following his last debulking surgery. So he never died from the tumor. He just died from the 4th surgical debulking. So.
And by debulking, you mean they were just doing a removal of tissue?
Yeah. So
okay.
He was on metabolic therapy and the tumor continued to grow and they would cut it out and it would come back slow. And after several more years, they'd cut it out again. It was really funny because at the beginning, when he was first diagnosed, they said he had an inoperable tumor. And if he didn't take a large dose of chemo and radiation, he would be dead in 12 months. And he didn't take any radiation or chemo. And then he just did metabolic therapy. And after 2.5 years, the tumor that was supposedly inoperable became operable.
Because it wasn't it was metastatic. It wasn't attached to everything because you guys had shrunk it down and defined borders.
Well, we shrunk it down, but we still never got rid of it completely. So we never cured Pablo, but he lived 10 years. I mean, and he didn't die from the tumor. So we don't know how long. And we talked to him a week before he went in for the surgery. He was laughing and we were having a good time. I was so sad when he died. He came out of surgery doing fine. Thumbs up. I get a picture talking up a storm. And then that night he had a cerebral hemorrhage and passed away. But the issue here, he was managed. So I like to call cancer, we can manage cancer, effectively manage cancer. Are you so fortunate to be cured? I don't know. If you get cancer at 35 years old and you die at 98 years old from a heart attack and the cancer never came back, well, you can say he was cured of cancer, that's for sure. But who knows? We never like to say the term cure because after 10 years it could come back. And we don't know if it would come back as the original type or come back from one of the toxic treatments that the patient received. It's not clear. So we like to say successful management. We are capable of successfully managing cancer, changing its diagnosis from extremely aggressive to indolent. So that I am sure of. I never can say whether you get cured or not. We don't know. Nor can the field tell you you're going to be cured. So the standards of care do not guarantee cure in any of these situations either. So, but I think we can do a hell of a lot better job than what's currently being done.
Yeah. No, I think That sounds amazing. This management alone, you know what I mean? 10 years on glioblastoma, that's like unheard of, right?
Well, it's not unheard of, but it happens extremely rarely. It's so uncommon.
Hmm.
And now we're getting in the Greek study where they did have radiation to the brain, because it's almost like they got a lock hold on that standard of care. Even in Egypt, we couldn't get them to not irradiate the brain. But my colleagues in Greek, they still irradiated the brain, but they had out of the 18 people, 6 went on the metabolic therapy, the calorie restricted Mediterranean, and 12 didn't for various reasons. And of the 6 that did metabolic therapy, 4 survived 3 years or longer, whereas only 1 out of the 12 survived 3 years or longer. So clearly, huge difference. And we didn't irradiate the brains on these people. These guys, we would even have better results. So we know what to do and how to do it. It's just that nobody is doing it, and they're putting their big toe into the water slowly on this whole thing.
Now, how did Pablo hear about this protocol and what you guys were doing?
Yeah, well, he talked to Andrew Scarborough, another guy from England who's still alive, and he had a stage 3 astrocytoma 15 years ago, and he's still going strong. So Pablo Kelly was from Devon, England, and Andrew was from London, and Pablo just heard about it. Pablo emailed me right after his diagnosis and said, "I hear you got some sort of a diet thing." And at that time, we didn't know we didn't know how to target glutamine. He never took a glutamine targeting drug. Can you believe it? He lived
So all that
long.
time and no glutamine targeting.
No, just on the metabolic
sugar.
therapy.
Wow.
Yeah, yeah, and he
Incredible.
learned a lot about how to do this. Now, Andrew Scarborough has been following his glucose-ketone index for all these years, and now he even knows without even measuring anymore. He knows what state his body is in, just for the fact that he's been doing it for so long. And he's writing a couple of papers. So the word of mouth gets out, and people just want to say, "Can I try it?" And the idea is they're living longer. Not everybody, but the majority of people who do it right, and if they follow our new big treatment protocol, the probability of them surviving longer is much greater than it would be if they didn't follow the protocol.
Yeah. Yeah. So now, are there any clinics that have sort of just taken this on as is there it seems like when you hear about cancer, someone's like, "Oh, yeah, my friend flew to France and he was there for 4 weeks and he doesn't have cancer anymore." And so are there any clinics that have just taken this and said, "This is going to be what we're going to do from here on out"?
Well, it also, no matter what country you're in, they got that strangulation hold on you for what you're supposed to do. I've never seen anything so pervasive about poison and radiation that they do everywhere, almost the same. But Istanbul, Turkey, we're starting some clinics over there where they're getting really, really good results. And the key thing is we have to publish these. You see what I publish things. A lot of clinicians don't know how to do this. They say, "Oh, I got spectacular results. You can't believe this patient. He should have been dead. He's out now swimming in the Mediterranean. He's doing this." Well, that's all anecdotal. Give me the data. Show me what you did. Let me see the blood work. Let me see the size. That's what we did with Pablo. We published all this stuff.
Yeah.
And let the clinicians see the evidence for themselves, what we're doing here. And in Istanbul now, they're using our metabolic therapy, and they're getting spectacular results with pancreatic cancer. Many of these folks are making 5 years, and advanced pancreatic cancer is usually a death sentence. We're getting good results, and they want to work with me to publish the papers. So I said, "Yeah, well, you have to collect the data on these people the way we collect the data on our preclinical studies. We have timelines, we have blood measures, we have biopsy. We have in the preclinical we can certainly do all this stuff, but we have solid evidence for success, and you have to present the most evidence to make the most disbelieving clinician a believer, because he said, "Well, you didn't do that, you didn't do this, you didn't follow that, you didn't follow this." We want to follow everything, all the imaging, the PET scan, the MRIs, the CAT scans, the blood work, the size of the tumor, how the patient feels, everything about this condition, to prove beyond a doubt that this guy did in fact have a terminal cancer and he's still alive. So, and I want to say terminal cancers should no longer be considered terminal when treated with metabolic therapy. We don't know what terminal means. We're all terminal to some extent. I mean, right?
Right. But if you're living,
yeah.
you're dying.
Yeah, you're supposed to be dead, but you're alive. What does that mean? But anyway, we're getting more and more, and I'm publishing these papers. It's not easy to publish a human report because there's so many variables. The guy decided to go out and have a party one night. Well, man, our mice in the cages don't do that, So one of my colleagues said, if we could take the cancer patients and put them in the same kind of cages that our mice are in, we'd have these cancer managed very quickly.
Yeah.
But
Right.
you can't do that. You can't do that. So, but anyway, we're going to work with these people in Istanbul and some of the other countries. In India, we've got a big group in India that are very excited. And Brazil, we got another group. And in China, we're starting to get people all over the world that are starting to realize that the science is solid. Why are we not doing anything about this?
Right. Right. So, one of the reasons I started this podcast and the reason it's called the Healthy Wealth Experience is because as a financial advisor, I can tell you, like, if you're not feeling well, if you have type 2 diabetes or you have cancer, you have these things kind of going on, it really doesn't matter how much money you have. Like if you're not feeling well, the only thing you want to do is feel better. What are some of the things that people could do to reduce their risk of developing those cancerous cells now knowing what you know?
Well, that's part of our new paper that's under review for chronic diseases, which includes cancer. If you can't, it's very, very difficult to get cancer when the mitochondria in your cells are healthy, because cancer is a mitochondrial metabolic disorder. So you have to abuse your mitochondria in some populations of cells in some organ of your body in order to cause that cell or group of cells to start growing in a dysregulated way. So if the mitochondria are healthy, and this has been seen in animals in the wild, humans living according to their traditional ways, where cancer is extremely rare. These people are always in a kind of a state of some semi-nutritional ketosis, which makes the mitochondria super healthy when you're burning ketones. Very unlikely that you're going to disrupt oxidative phosphorylation. When we develop when the GKI comes out in this new format, people will know that if you keep a GKI below 20, your probability of getting cancer is going to be remote because you're keeping your mitochondria healthy, and you'll have a quantitative measure to know that. Right now, we don't know that. And if you have in a very yellow, good orange, green zone, and you go out, you binge at a party and whatever, you'll see go up deep into the red. But then you can take action right away to move out of that zone and back into the healthy zones, which will obviously prevent type 2 diabetes, cardiovascular disease, cancer, dementia, all the chronic diseases, because they're all based in one way or another on mitochondrial dysfunction. So if you keep your mitochondria healthy, you don't get chronic diseases or cancer.
Right.
But right now we're living in an environment that puts us at risk for all of these chronic diseases. We have an obesity epidemic. We have a lack of exercise. We're eating buttloads of highly processed carbohydrates. We're emotionally stressed out to the max. We're locked into these computers and cell phones, and you're doing everything possible to damage your mitochondria health. And people need to know that. And then there's no longer a mystery. I can't tell you. I mean, I'm seeing it because I get thousands and thousands of emails from these poor people. Cancer in young people used to be mostly old folks. Now you're getting people in their late 20s and 30s that are getting colon cancer and all this kind of stuff. I said, what's going on? I mean, we're saturating our environment with all the crap that's putting our mitochondria at risk, and we're not doing anything about it.
Well, along those same lines, if you look at childhood obesity, how high it is now, that is the canary in the coal mine.
Yeah.
If you have a child who's morbidly obese, he or she is on his way to mitochondrial dysfunction.
Yeah, it's terrible to say. It's kind of like a parental neglect to put your child at risk for chronic disease when he's so young. And they don't know. That's the problem. The parents themselves lack knowledge about the gravity of what they're looking at. I mean, because they're morbidly obese, the child should be morbidly obese. But they have to wake up, because what it does, it's stressing our healthcare system to the max. Most of the money in the healthcare is going to manage chronic diseases. And RFK Jr., he comes out and says, oh, we're going to do something about chronic diseases. What, are you going to take a dye out of a Fruit Loop? Give me a break. And he's all digging holes with vaccines and autism by tile. I mean, this is nonsense stuff. We have the strategy to manage chronic diseases, and these guys are fumbling around with things that are not as critical as cancer and diabetes and these other things.
Heart disease,
so,
yeah.
Don't ask me what's going on down at when they say cancer is a genetic disease on their website. I know they don't know. They're asked from a hole in the ground.
Oh, yeah. Yeah, definitely, after hearing this, it makes me, want to advocate for it even more and get that knowledge out to people, like what can people do to sort of push the narrative? Obviously, I have the show, and that's a way, for me to push it out.
Well,
is to get it out to the, all the social media channels and things like that. But like, are there things that we can do as a community that could kind of get these? Because again, like I feel like a lot of people don't want to question a doctor.
yeah, I
when
know.
doctors are just using the best information that they have, which means we want to give them better information.
Yeah, I know it's such a hard thing, and I can tell you how many people get slapped down when they get all excited hearing what I say, and then they go into the oncologist and they get slapped down, or that we don't want you as a patient anymore with those kinds of questions. And it's so hard. It's so debilitating to hear that. Go eat whatever you want. Glucose has nothing to do with anything. I mean, it's like, oh man, it's so tragic. And I feel bad for everybody. I feel bad for the lack of knowledge on the person who's supposed to be treating you. And I feel bad for the lack of knowledge on the patient who's suffering with the disease. And it's just such an unnecessary situation. But the firewalls and the barriers to moving this forward are so tall and so numerous. It's just, I think what you do and what all these other podcast guys do are what you can do. You put your word out there. And the interesting thing is that all of the research that we do here is supported by philanthropy and private foundations. We don't get money from the government because when I write grants, they always ask me what gene is involved. And there's no gene involved, man. It's a metabolic problem. And they're always asking you, oh, but you got to detail the smallest amount of minutia mechanism. I said, we have a way to stop the death, the slaughter, and you're worrying about a mechanism that may have no relevance to the problem. But that's the way scientists work. And in some cases, that's absolutely essential. But we have a critical situation here. People are dying by the thousands, and it's unnecessary. And the more I publish my preclinical studies and the more we investigate synergies between diets and specific non-toxic drugs, or learning how to take a previously toxic drug and make it non-toxic because now you have a better way of knowing how to use the tool, this is going to advance the field and drop death rates. There's no question about it.
Right.
So we have Travis Christofferson's Foundation for Cancer Metabolic Therapy supports our work. And people say, I just want to support you. I don't care if I make any money on it. I just think what you're doing is important. And it is. And that's the way we keep publishing the papers in top peer-reviewed journals. And eventually a tipping point will come and a paradigm shift will happen. It's just that it's not there yet.
Yeah, no, it's exciting though. It's exciting to think that it could be right around the corner. And then again, as a financial advisor, I'll tell you, if you're listening, and you've got your beneficiary set up for your trust, why not name these guys for a portion of your trust to help with the research? Why not further research where we know it's doing?
Yeah, we have people that have given some parts of their estates to Boston College. Mm-hmm. To support our cancer research here directly through the university. And then we have the private foundations. I get guys who say, I have pancreatic cancer. Here's $100,000. Can you help me? But it has to go through the university. I can't accept any money personally from anybody. But they're anxious because they know what we have can keep them alive. And the bottom line is, how do you perfect this?
Well, I think. So anyway, and I think you mentioned like the NIH is really not going to help with this or the American Cancer Society, they're going to help with it because they're basically, I don't know what, I want to be real careful how I say this. They're directly influenced and sometimes monetarily influenced by big pharma. So, and if the way to cure cancer is not to take a $16,000 a dose drug, then they would have no interest in that.
Yeah, well, that's true to some extent. And it happened in 1984, actually, when progress towards managing cancer was stalling. And in 1984, at the NIH, they made a decision to bring in the pharmaceutical companies into the NIH and academic cancer labs to kind of expedite the race to the solution, which has now led to us an even more disastrous situation because we've replaced outcomes with profitability. So revenue generation becomes the most important thing rather than patient outcome. And raising money for cancer, like this is Breast Cancer Awareness Month, so you see pink ribbons everywhere. And people they use the good nature of people, and they use them as mules to raise money for these organizations with no accountability of where the money goes. Raising money has become an end in itself rather than a means to helping cancer patients. And when you look at the advisory board of a lot of these organizations, they've all published papers saying cancer is a genetic disease or in one way or the other. So you're really throwing good money after bad. It's not helping anything. The people get help most of those that are running and swimming and biking for the organizations. They get healthier doing that.
Yeah.
But once you raise the money for whatever they're doing with it, all we do is get more dead cancer patients. So clearly a whole system needs to be reevaluated. It's broken. It's broken from top to bottom.
So if someone's, I want to be respectful of your time. We've been talking for about an hour now, and I could probably do this for another 6 hours. This is just so fascinating to me. But I guess what I would say is, like, what could someone listening to this, what could they start today? Let's say they don't have cancer. They just want to be better off and they want to lower risk of cancer. What's something they could do today to lower their risk and say, hey, from here on out, I'm never going to do this, or I'm always going to do this, or I'm going to try to be better at.
Yeah. It's hard. I mean, I know what we have to do. You can do more exercise for sure. I think that's clear. Walking, it's just even a little bit of exercise is unbelievable in reducing risk. But people are stuck in cars and traffic. You ever go to the big cities, man? The traffic is killing everybody. Books on tape. You run home, kids are yelling, let's throw something in the microwave. I'm not going to go out in the backyard and chop the head off a chicken and pluck them and then cook them tonight. And the healthy foods are more expensive than the cheap foods. So the cheap foods it's really, everything is like stacked against us in trying to be healthy. But once the GKI information comes out, people will have a tool that they will be able to use. And there will be an app associated with that, so you can look directly on your cell phone at any given time. And then you could be able to make choices as to both prevention and management, whatever the situation might be. And that we're working as hard as we can, and we're doing it on a shoestring budget, if you can believe it. Some of our people working on it, they're learning how to program. They're learning all of the skills needed to build this thing. And then we have to work with some of the companies so that they can mass produce these things so people can have it. Yeah.
Right.
So there's a lot. Listen, there's going to be monies to be made. It's just that I don't know. I'm not one of those. My job is to see how many people I can keep alive.
Yeah.
That's rewarded in itself, only to prove that you knew what you were talking about. That's the bottom line. Did you know what you were talking? This guy giving you a load of bullshit, or does it really work? And the science tells us it will work when it's done correctly. And once that happens, and you start to see everybody who would be in these terrible situations in a less terrible situation, then you achieve the.
Yeah. Well, I know that a lot of people, when it comes to, getting later on in life and stuff like that, people start to focus on legacy, and things that they, can leave to the planet. And I think it's without a shadow of a doubt that you've left a tremendous legacy that's going to change the face of the planet. So I thank you for that, Aaron.
I won't be around to see it.
Well, maybe if more things like this podcast can get out there, we can start putting pressure on people. I'll be part of the
planet. At that time, I'll be part of the planet.
Yeah, right. I love it.
But either way, it's going to work because the science is so strong. And don't forget, we're standing on the shoulders of the giant out of Warburg.
Yeah.
Who is Germany's #1 biochemical scientist. So it's not like we just cleared up a lot of the misinformation and misunderstanding that he had. We've just cleared it up and made it that he was right, but he just didn't have all the details that we now have.
Right.
So there's no reason now to rocket ship forward with this.
Well, the glutamine as a fuel, that's really recent, right? I mean, you just came out with that published.
Well, no,
right?
no, actually, that's not all the oncologists. Well, academic scientists in oncology know glutamine is a major fuel, but they all thought it was respired. Our new discovery was that it's fermented. It's generating energy without oxygen. That's the new thing. That's a mechanistic new revelation. It's fermented. And we worked with the #1 scientists on that mitochondrial substrate level phosphorylation, which is a fermentation mechanism inside the organelle that generates energy through oxidative phosphorylation. That's what Warburg did not know about, nor does the field of science. So everybody knew glutamine was involved, but they just didn't know the mechanism by which it was involved. So now we know what it's doing and we know how to stop it. And now you should be doing that.
That's great. Okay, so I have to ask, how is your diet?
Well, I try to skip as many breakfasts and get as much exercise. I'm very fortunate to have a palatial gym that we now build for our undergraduates here at the universities. Your university is dictated more about the size of your gym and your athletic facilities than it is about the size of your library. So 4 stories of just every kind of a exercise machine and swimming and everything, which puts me in a good position because I just walk out the door and just over on the other side there is this beautiful gym. But I know so many folks in our society are stretched and they don't have that capability. But there are other things that you can do, and a lot of it is pointed out in our big protocol paper on the glioblastoma, things that people can do, just small things that can put them on the right path to keeping themselves alive longer with less chronic disease.
Where can we get a copy of that paper?
It's open access. Which means that anybody with a computer can download it. It's the treatment protocol for glioblastoma by Dr. Thomas Duraj, Duraj. I'm the last author on the paper, but we have 20 or so authors on this paper from all over the world. All corners of the earth are on this paper. But it's a very detailed, elaborate. Yes, and what we're learning is that I always said there's some level of scientific literacy essential to knowing what we're talking about. But now with AI, all these terms and things like that, you can just throw them into the Google AI and they come right, they explain everything to you.
Right.
So we can use AI to our advantage to help us wade through what this guy is saying in this paper. And my lectures are less technical, unless, of course, I'm giving it to a professional technical audience, at which time I can go to the greatest depths that they need to know. But the guy on the street, all he wants to know is how do I do this?
Right.
What should I eat?
Right.
And the answer is, well, once the tool comes out, you can do it now. You'd have to go on and buy a Keto Mojo. Now the tariffs made the damn Keto Mojo. You can't get them. So it's hard to get. We can just prick your finger. Maybe Precision Extra might have one from Abbott Labs, but you can measure your own GCAT. We published a paper already on that, on the Glucose-Ketone Index. We did the calculations for everybody, but people like to just push a button and have the number appear right in their face. So that's another convenience that they've worked on. So, but the things are there. They're just a little bit less convenient now. And we're trying to bring the convenience to everybody much easier.
Yeah. Well, I will find that I'll find that publication and I'll make sure I link to it in the description.
I can send it to you.
Okay,
I
perfect.
can send it to you. And the press pulse therapy, I can send that to you.
That'd be great.
Concept. Yeah, I'll send them. And I'll even send you our new paper, which is pretty heavy, deep into the science, just for anybody that might be interested in going to the depths of the problem.
Right.
It's called the Warburg hypothesis and the emergence of the mitochondrial metabolic theory of cancer, which tells the field, where the mistakes were made and the science supporting everything that I'm talking about here.
I love that. I love it so much. Now, if someone wants to get a hold of you, what's the easiest way to get a hold of you?
Well, they usually email me. If I usually send them a kit of information. I give them a very detailed kit of information and names of people who they can, because I can't treat anybody. I can't tell anybody what to do, but I give them knowledge. And the only thing we ask is that they make a donation to one of the foundations, because I give the information free. I don't charge anything for this information, and then some people do make nice donations and a lot of people don't. Some people don't have any money, but that's okay. Whatever helps them out is fine. The goal is how much longer can I get emails back from guys, I give them this kit of information. I don't know. I don't hear from them. And then 2 years later or something, they email me. I said, "Oh, you're still alive." I said, "That's good news. You're still alive. I thought you would have been dead."
I love that.
It's always a surprise to hear somebody that has stage 4 cancer who's still alive years after they were supposed to be dead.
Yeah, that's so great. Dr. Seyfried, I really appreciate your time. And as soon as you come out with the continuous keto monitor, I want to be one of the first people to try it. I want to be on that thing.
We're all excited about that ourselves.
Yeah.
All right, Chris, listen, I'll let you go. Thank you for the interview.
Thank you.
And all the best, and I'll send you those papers.
Perfect. I appreciate your time. Thank you so much.
Okay. Yeah, thank you. Bye now.